given that f0 of x is x squared and fn plus 1 of x is f0 of x composed with fn of x, we want to find a formula for fn of x. Okay, here the easiest way is to use the definition here, and we try to find a formula that we when we find it, we're going to prove it by induction. Okay, you don't need to prove it, but this is how it works. To get something and to have some hypothesis about the truth of the formula, you need to prove it by induction. Okay, you don't have to, but we're going to do it anyway. Here, note that we start with f0 of x as x squared. To find f of 1, here, we're going to use this recursive formula. So to find f of 1 of x, we're going to compose here by, we're going to plug 0 here, and therefore we have f of 1 of x is f of 0 of x composed with f of 0 of x. Okay, this will give us f of 0 of x composed with f of 0 of x. By definition, this is just the image of f of 0 of x by f0 of x. So this is just f0 x squared. So the image of x squared by f0. This would give me x squared squared, which is x squared squared, or x to the power 4. Okay, so now I found f1. I can find f2 here now. So to find f2, I can plug 1 here, and I get f0 of x composed with f of 1. This gives me that f2 of x is f0 of x composed with f1 of x. And using the definition, this means f of 1 of x. I know f of 1 here, I found it. It's x to the power 4. So this gives me f0 of x squared squared. I'll find its image by f0. So this will give me x squared squared, everything square. Or this will give me that x squared squared times x squared squared. Using the definition of the exponent, this will give me that this is just 2 to the power 2 plus 2 to the power 2. And this means that it's x times x to the power 2 times x to the power 2 to the power 2. But this is just x to the power 2. This is 1 here. And 2 plus 1 is 3. Or I could have saved everything from here without going through all this algebra by just saying this is x to the power 4 squared, which is 8. Okay? But I'm doing it this way because I want to see a formula here. I can write this one as x squared to the power 2 plus 1. Okay? The same thing here, but this means that I might get something like this. Okay, so computing f2, I note that there is a 2 here that repeats all the time. So x to the power 2, but the exponent here. So this is 2, and this is 2. Okay, let's see if that works for 3. To do so, let's find f3 of x. So this gives me that f of x composed with f of 2 of x. Using the definition, this means that f of 2 of x by f0. That means I know f2 here. It's x2 to the power 3 squared. That means it's x to the power 3 times 2. Or I can write it as x to the power 3 plus 1. Okay? So now I can say that, so note that this is 3, So here I have x to the power 2 to the power 3 plus 1. And I guess my formula is fn of x is going to be x to the power 2, everything to the power n plus 1. So let's see if this works. So if n is 0, I should get x squared, because here 0 plus 1 is 1 and 2 to the power 1 is just 2. So when I plug 0 here, I get this one. So it's true. For f1, I should get x to the power 1 plus 1, which is 2. And I should get x to the power 4 or x to the power 2, 2 to the power 2. Here, I got this one. It's right. Let's see if that works for 2. For 2, I should get x to the power 2 to the power 3 or 2 plus 1. Here, for 2, I got that. I got it here. And therefore, I assume that my formula is this one here. Okay? Now, to prove this formula, to prove that this is the right formula, I need to use induction to prove it. So here I'm gonna call this statement P of n. So fn of x is x to the power 2 to the power n plus 1, and it's valid for n bigger or equal than 0. So here my statement P of 0 is true for n equals 0, for n equals 1, 2, and etc. So now I'm gonna assume that this is true for n, and I have to prove that it's true for n plus 1. That means fn plus 1 of x must be x to the power 2 to the power n plus 1 plus 1. It must give me x to the power 2 to the power n plus 1 plus 1. Okay? Or x to the power 2 to the power n plus 2. Okay? So how can I use this one here? How can I prove this? What means do I have to link this is the induction hypothesis with this one that I want to prove? I have a recursive relationship, this one here. So this is linking the induction hypothesis, this one, with this one. Okay? So I have fn plus 1 of x is f0 of x composed with fn of x. Using the definition, this is just f0 of fn of x. Now, I know the formula for this one. It's given by this. Okay, so this gives me that f0 of x to the power n to the power 2 to the power n plus 1. Now, this is the image by x squared. So this means that this is x to the power 2 to the power n plus 1 squared. Okay? I can use any mean I want. So here x to the power 2 times 2 to the power n plus 1. And this gives me x to the power 2 to the power n plus 1 plus 1. And this is what I need. This is what I need to prove. Okay, so here. Okay, here. And here. So this is, I showed that it's true using the induction hypothesis. Therefore, my formula is true. The general formula for these recursive functions is given by x to the power 2 to the power n plus 1 for every n greater or equal than 0. So this is the formula that I need. So if I want a f7, I just plug 7 here. If I want a 300, I just plug n equals 300. I don't need to do any of this algebra. I have the formula that gives me what I need. Okay, so this is all we have. If you see any errors or mistakes, please let me know. Thank you.